And two things are in direct proportion. If I was to plot them on a graph, and let's say y and x are in direct proportion, then I'd get a straight line, a constant gradient, and it would go through the origin. So that means when you take y is equal to mx plus c, you've got c is equal to 0, so you just get y is equal to mx, and you rewrite that as y equals kx typically, where k is called your constant in proportionality, but it is essentially the gradient. So that's something to just be aware of. And we write y is proportional to x. We could write x is proportional to y instead. So that's what we're going to use here in this slightly sneaky question on direct proportion, because I've got three variables, in fact, and I'm trying to find z in terms of x. So when it says y is directly proportional to z, I might write that y is equal to kz, for example, because I want kind of z as the main thing. I'm going to write z is equal to my, and then I'm going to write y is equal to kx. If you do it the other way around, you'll just get a slightly different constant proportionality. It will all work out. It's just that you might get some fractions going on, which I'm going to avoid. So the main thing now is that because this y is the same as this y, I can simply write that z is equal to m k x. And I've got a formula for z in terms of x. I just need to now work out what m and k are, and I can do that because I've got these two conditions here. So if I substitute them in, I can substitute this into here. So it's going to be 60 is equal to k times 10, and that means k is equal to 6, and I've got the first unknown. If I then substitute this into this one, I've got 1.6 is equal to m times 8. I can rearrange this. M is going to be 1.6 over 8, and that's going to be 16 over 80 if you want to rewrite it like that. Actually, that doesn't help. 0.2 if you use your calculator or do short division. So then finally, we're basically there. Z is equal to 0.2. I'm just substituting into here now my values of m and k. 0.2 times 6 times x. Z equals 1.2x.